So I know it's late and your guys are tired. I mean, there's no hands-on here, but it's sort of a tutorial. So there are like steps you can follow if you wanna follow the things I'll be presenting. But more, it's like giving you information of what exists out there in terms of how you can build IoT applications, what sort of hardware is available and software, and how you can make cool stuff. So I'd like to start with very basic things, how we can build IoT applications, and let's start with what are the main components for building applications. So we got devices like the Galileo boards or the Arduinos or devices from other vendors, and we make them connected so we can put them inside objects that are a bit damp and have no functionality or no a way of processing information, and we give them connectivity to some network and preferably to the internet, and on top of that we build some online services. And there's the whole interaction going with between all these main components. So within this presentation I'll try to explain or give you ideas of what we can use for its different components. So starting from the devices, you've got your Galileo boards in front of you, but there is a huge selection of tools and hardware devices you can use. It all started with the Arduino 6-7 years ago. It was never meant as an IoT platform, so by default there's no connectivity. It's a platform for creativity. You can easily use to program it and interface with hardware, connect sensors and actuators. But there are many ways to connect an Arduino online. So out of those who have played with an Arduino before, who of you have played with an Arduino that they made it connect to the internet? Hands? Okay, a few. So yeah, we'll see how this can happen. There are many ways to do that. You can use Ethernet, you can use Wi-Fi, you can use different types of networks. The most direct way to connect an Arduino board is, of course, to use Wi-Fi. Why? The answer is because everyone has a Wi-Fi router at home. So you don't need a special gateway. If you follow this link, postscapes.com/Arduino Wi-Fi, and I'll give you the slides, you can find all the available boards that allows an Arduino to be Wi-Fi enabled and connect to the internet. We got OpenPicus, another Italian company. They make the flyport devices that come into 3 different modules. They support Wi-Fi, Ethernet, GPRS, and Enocean. Do you know what an Enocean is? So Enocean is a company in Germany that they do energy harvesting. So you can have a switch on your wall that has no power supply, and just by clicking the switch, it can transmit a signal to your flyport or to your Arduino, and you can get this event. Likewise, they have sensors that can get energy from the ambient light or the ambient temperature, and they can operate without using a battery source. How they do it, they use special RF technology, which is not compatible with Wi-Fi or whatever else, and thus you need a special gateway. So these guys have got a special module that you can connect to their system, and then you can have this connected to the internet through Wi-Fi, Ethernet, or something else. Libelium, a company in Spain, they do a lot with Zigbee. They're very popular in mesh networks and smart city installations, especially in Spain. Embed by ARM, almost old enough as the Arduino, different type of processor, a bit more powerful. They have a web-based interface, so you don't have these troubles with connecting and setting up the IDE. It's totally web-based, very interesting as well. We got new devices coming up either through crowdfunding campaigns or startups like Pinocchio, which is sort of device that can create both a mesh network. So they have their own RF technology, and you can put different modules, and there is they can communicate hop by hop. So if one module cannot talk to the gateway, it can talk to the other module next to it. And by doing this, they can reach the gateway that can support Wi-Fi and talk to the internet. We got the Sparkors, and I got a couple of them. They're really cool devices. They are really, really small, about this size, and they are Wi-Fi enabled Arduinos. You just plug power, and you use an Android or an iPhone application to put the Wi-Fi credentials, and then they connect to the company's cloud, which is also open source and free. And what you do then, you go to the cloud and you write your Arduino code on the cloud, and automatically it transmits to the board so that you can program it remotely, no matter where you are when this little guy is. To do that, they utilize one of the new, let's say, M2M, very popular protocols in the IoT domain, Co-op. Have you ever heard of Co-op? Okay, cool. Yeah. Electric Imp, I think they started like 2 years ago. They're US based and they're more focused on building actual commercial products with Wi-Fi and connectivity. It's very low cost, it's about $30, but the really cool thing about it is that it comes in the form factor of the SD card. And that thing over there has Wi-Fi, so all you need is an SD card slot, and you put this thing inside, and then it has an interface, you can attach sensors, actuators, and then also there is a cloud-based interface where you push your code and it goes there directly and it works. Another cool board is called Tessel. It's this one. It has similar form factor to the Arduino. It comes with Wi-Fi, and the very interesting thing is that you can write JavaScript, Node.js directly on it. More boards, SODAC. It's an Arduino board where you can change the communication module, so you can put a Wi-Fi, XB, RF, whatever you want. Xion RF, a company from the UK are making it. They're based on RF, so if you want longer range communication with the gateway, you can use that one. Advanced apps, Intel boards. This one is brand new, just the evaluation board of the new Texas Instruments wireless chip came like a week ago, and the interesting thing is that it's very low cost. It costs about $30, and you get the whole board with the Wi-Fi and the microcontroller you can use to program it. And the cool thing about it is that it's the first Wi-Fi system on a chip that supports TLS and HTTPS. So if you are into security or you ever try to connect your Arduino or a similar board, something much less powerful than Galileo or a Raspberry Pi, if you wanted to do secure communication with a REST service through HTTPS, it's impossible because they don't have the resources to do TLS. But this is now changing with this chip here that is also very low cost. And of course, there are many boards that are domain specific. So if you want to work with wearables and you want to play with Bluetooth 4, there's Bitolino and many other things. Again, if you go to this website, postgapes.com, you can find a great list and compilation of the different boards for prototyping and do-it-yourself stuff. Gateways. Why do I need a gateway? Who can answer that? Come on. Why do I need a gateway if I want to connect my device to the internet? Yeah, so I mean, actually, eventually, whatever you have, even if it's a smartphone or Raspberry Pi or Galileo, you need a gateway. There's no direct connection to the internet. I mean, we consider direct connectivity Wi-Fi because we have the Wi-Fi router, but at the end it's also a gateway. But the correct answer here is that Wi-Fi is not meant for IoT, and it doesn't mean that because we all have it at home, it's the best solution. So you might find yourself in cases when you want to build something that doesn't consume that much power. It's much cheaper. I mean, you can buy a Wi-Fi module for about $10 if you buy massively from Texas Instruments. But if you buy a simple RF transmitter, a pair that can receive and send data, it's like $2 or $3. So the difference is really big if you want to make a huge number of devices and deploy them out there. So at some point you need a Galileo board or a Raspberry Pi with this RF transmitter and then an Ethernet module or a Wi-Fi so that it can connect all the devices to the internet. And you got the Raspberry Pi, Galileo, BeagleBone, and many other devices. And this is how commercial gateways for the Internet of Things started to happen, like the smart things. I'm sure everybody knows about the smart things because they went really big on the Kickstarter, and recently they got bought by Samsung for a huge amount of money. And the truth is that when they started prototyping before going to Kickstarter, they started with an Arduino and Raspberry Pi. So, okay, we got the devices, we got many options to select from, and we can put things. What sort of things we can put? Many sensors and actuators. So sensors, you already have a few of them in front of you, and there is a very huge collection. It's called Groove Sensors, and they're made by a company in Hong Kong. It's called Seed Studio, and they have this really nice form factor that you can easily attach cables on the shields, so you don't have to mess up with breadboards and make sure that you connect the grounds correctly, things like this. Yeah, I know, sure, it's Groove Sensors. So there is a huge family of sensors you can select from. So you can have ambient sensors like sensors that can detect the air quality, barometric pressure, and they can forecast the weather, temperature, light, sound. You can have motion sensors, flex and force if you want to build wearables. There are many examples out there with gloves that can transmit the motion of the hand into signals, and you can do cool stuff with robots and other things. Positions like gyroscopes and accelerometers. There are sensors about magnetic fields, electricity, so if you want to build a project that can measure the power consumption, it's really easy. You can find the devices on Seed Studio and also in Europe, and you just plug them in. Biometrics, they got biometric sensors. They got sensors that you can put them on your body, like a strap that they can measure the heartbeat, and you can get this information as a digital sensor. So they give you a high pulse when your heart beats. And this here is a GSR sensor, so you put them on your muscles or your skin, and it can detect the galvanic skin resistance of your body. So you can build a lie detector or a stress detector and cool stuff like that. And they all come with sample codes, mainly, especially for the Arduino, so you can find pretty cool stuff and do many, many things. What can you actuate? So, I mean, okay, sensing is good, but at some point you need to drive some outputs to do things with the boards. So you can move things, you can attach motors, and there are different kinds. You can activate things, you can put a relay switch, and you can activate bigger circuits, so you can turn on and off a lamp or another big device. There are interfaces, so you can attach directly speakers to your boards, you can have sound, you can have light, you're already played with LEDs, you can have displays, and of course we have all the remote web-based interfaces, so like social, email, text, Twitter. I mean, these are all ways you can get the information from the boards and publish them online and distribute them. How do we program the devices? The Arduinos mainly. So usually all sorts of devices come with an IDE that you are either installed on your computer or it's online. So for the Arduino, we got the Arduino IDE. There is also an Eclipse plugin you can install and use it. There is software for people that are not very familiar with the C language. So have you ever heard of Scratch? So Scratch is an MIT project. It's really cool because it's meant for kids. And the way they do it, it's a really cool graphical interface, and you simply take sort of blocks together and you teach kids let's say, how to learn to think programmatically. So you can teach them easily controls like if then else and while loops, and all this goes graphically without even writing a single line of code. They just put the blocks together, they match them together, and they simply change the parameters, and then they see the output on the Arduino, so they can change the LED blinking frequency and stuff like that. It's really cool. Cloud-based interfaces, so even if you don't have a SPARC core, but you still want to program your Arduino Ethernet or Wi-Fi remotely from the cloud, there's the Conbender open source project that can help you do that. And the browser-based interfaces like the Embed or the Arduino and other ones. Feel free to stop me for any questions or whatever at any point. Workflow-based programming. Has anybody heard of Node-RED before? Cool. I'm going to spend some time later on it, so I'll skip this slide. How do we connect the devices? Many different options, many different networks. This is a cool graph from a friend of mine in Postscapes. So yeah, we got, depending on the range, we have many options like Wi-Fi, longer range RF, Zigbee, Bluetooth if you want to do wearables, and short range, and also depends on what sort of limitations and requirements we got for battery utilization and things like this. Many options. Just keep in mind that there is no golden solution for the best connectivity. Even if it's just for home automation you are designing your solution, it doesn't mean that you have to go with Wi-Fi. It can be Zigbee, it can be RF. It really depends on the setup, on how often you want to transmit data, and again on power and battery utilization. Protocols. Let's talk about protocols. So, typically when you want to push information from your device, your Arduino, to some web service, some application on the other side, you use REST and HTTP. So, post, put methods over HTTP, you push data. Now, lately, with the introduction of HTML5 and WebSockets, people also implement libraries for the Arduino that allow bidirectional communication, like WebSockets. Have you ever heard of WebSockets before? Probably did. Have you ever worked with WebSockets? Okay. But still, WebSockets is over HTTP, which is considered to be a bit heavy for machine-to-machine communication, and mainly because it has a big overhead that is not needed in some cases. So in some cases, you want to do bidirectional communication with the devices in an easy way and with the least overhead as possible. So this is why there are many so-called machine-to-machine protocols introduced. So we heard a bit about MQTT before, but have you ever used MQTT to build anything? You're out of the...
Yeah, it was sweet as well, and you have examples.
Yeah, sweet. Co-op was specially introduced for IoT applications because what it does, it takes the REST notion, so you can consume data by following the same RESTful notion, like you can make GET requests, put requests to get data, but also you can subscribe to notifications. So it's the lightweight end-to-end. And of course, there are already established and used bidirectional protocols that are based on messaging, like XMPP and STOMP. And it really depends on how compatible you want to be with other applications that exist online. But if you need bidirectional communication, there are many options to use, and there are many also clients for your Arduino devices or the other hardware devices that you might use. Online services. So what are the applications? You can push data. Really many. So we had the first one publicly available that actually made this big change was Patchbay. I think they started in 2008, and even 1 year later, the big company in the US, LogMeIn, realized the value behind it. And before everybody was talking about IoT, they bought them and they invested in them. So then they chased the Cosm, and today there's Ively, but there are so many others like Paraimpu. You saw a few examples. It's the ThinkSystem.io, ThinkSpeak. Almost everybody is building an IoT platform, and I don't understand why. Who is working on IoT European project here? Okay, hands down. Are you building a platform for storing data? Yeah, okay. Anyway, there are dedicated also services for doing device management, if you want to check the health status of your device, or if you want to distribute new code. And some of them also are providing full platform as a service. Do you know what a platform as a service is? Okay, so platform as a service is that when you want to put your application somewhere in the cloud and you want it to scale no matter how much data or how much traffic you send, but you don't want to do the whole thing, like set up the load balancer and the application server. There are services that provide this. So you just write your code, you put it there, and it scales. For example, the Google App Engine is one example. Node-G2 is another one. There are many out there. And there isn't anyone yet that is, let's say, dedicated to IoT other than Bluemix from IBM. Have you ever heard of it? So it's a new platform as a service by IBM that is sort of focusing on the Internet of Things. And also this is what we are trying to do in the project, but I'll come to that later. So yeah, we've seen a bit the online services, mainly the features. What you need to do is like store data or get data or do device management. And we've seen that there are different protocols you can follow to build your IoT applications and many devices to select for prototyping. And now I'll go to the theme of my presentation here. So IoT and JavaScript. And let's start with a question. I mean, why JavaScript? Do we have any web developers here or web designers? Oh, okay, sweet. So the rest of you are just academic or embedded guys, full into C and stuff, more or less. Okay. So the answer to the question why we're talking about IoT and JavaScript is in a few graphs I'm going to present now. So this graph was released recently, a few months ago, and it's the percentage of the new GitHub repositories that are published. And I believe you can see the trend by yourself. So it doesn't mean that everything will, everybody will start coding in JavaScript. Of course not. But it just shows that JavaScript is becoming very popular for doing things like web applications, and in the IoT world also for prototyping. So what this could mean for especially those of you who are working in European projects and you want to actually attract external developers and communities, and you want to make sure that people will find useful of what you're building and they're going to maintain it, please make sure that you sort of have in mind this kind of graph, because if we deliver software that is not very popular, people are not going to use it. Let's dive specifically into the IoT domain and JavaScript. So if you go on GitHub and make a query about co-op libraries, this is what you're going to get. So based on the best match, so the first one is JavaScript, then we got Python, then JavaScript again, and then we got C++, which is the Arduino client. For some reason, no Java. If we look for MQTT, the most popular one is JavaScript again, then it's Java, then again JavaScript, and then the most well-known Arduino client. WebSockets. Yeah, for some reason, Go is much more popular than Python, maybe because still on the back end, people are working a lot with Python. But yeah, JavaScript is following. So yeah, all I'm saying is that, I mean, we should avoid building things from scratch. So when you either want to prototype something, you're a startupper or an entrepreneur and you want to build a proof of concept, you're going to find many modules made by JavaScript, especially for the backend. So data visualization, processing, hosting, many things. Just keep in mind. And of course, libraries that enable this, provide these IoT protocols. So bidirectionality through co-op, MQTT or WebSockets or whatever. So yeah, a few things about now platforms that are actually based on JavaScript and provide something for the world of Internet of Things. So software-wise, one of the first applications, let's say, was the Arduino. It's a very simple open source framework that you can, it runs within your browser, and what you can do is that you can plug in your Arduino, you put the standard Firmata sketch, and then you can do anything you want on the browser. So you can actuate, you can change the state of digital pins, you can read analog pins, and do many things. And you just follow the typical JavaScript code structure you would use. You don't need to worry about C or anything else. So if you have no idea about C programming and embedded programming, how to program Arduino, and you are a web developer, this is for you. Device.js, similar concept, also based on Node.js. So you can do the same thing. You upload the standard Firmata sketch on the Arduino, and you plug it in, and then on your Galileo board or Raspberry Pi, you can do all the programming, all the logic on Node.js. And now let's talk about Node-RED. So Node-RED is a graphical tool. It runs within your browser, and it's meant for building Internet of Things workflows. It's fully open source, and of course it's free, and it's becoming really popular. So what you get once you install it requires Node.js, of course. So you get this environment where on the left you have the different nodes, which are the building blocks. You can just drag in. So you have building blocks that talk to the Arduino, talk to Beagleboard, talk to online services like Twitter, and many others. So you just drag them in here on your composition editor, and you just create the flow. You connect the inputs and the outputs and the logic. There are function also nodes where you can double click and you can add your code. So if you want to add some logic, like I get this input from an Arduino pin and I check the threshold, or I do something more advanced and I provide an output, that's the way you do it, using JavaScript, very simple. And then you just deploy and it runs. And on the other side, it's like a serial console. You got the debug information. So whatever goes in, you can have like system printouts, and you can read the information that comes from nodes or goes out from nodes. So there are already, by default, many nodes available that are built from the team behind Node-RED for doing transformations, social interaction. So you got the Twitter node, Twilio, email, XMPP, all those stuff. Storage, if you need to store your data. So if you actually want to build an application that takes data from sensors process them and stores them, then you can use whatever you want, the local file system, MongoDB, MySQL, Couchbase, anything. Communication, you have your HTTP nodes, so you can make requests to other services, HTTP request and get data. You can host HTTP applications, so it's an application server, so you can produce HTML files. MQTT, WebSockets, you name it, it's in there. Hardware, if you directly attach to the computer that is running the Node-RED, your Raspberry Pi, your Arduino, or your BeagleBoard, there is full support, so you can easily just drag the node and say, I want to read from this pin, or I want to set this pin at this state, and it works. And also it comes with modules for doing analysis, like sentiment analysis of Twitter, statistics, and various stuff. The cool thing is that it's totally open, and they're building a really large community around it. So people are continuously contributing nodes. So it's less than a year old, or about that, and there are more than 40 contributed nodes about different things. I was one of the first persons who contributed to this, and I built a Philips Hue node. Do you know what a Philips Hue is? So it's the connected lamp from Philips. You buy, there is a gateway, you connect it to your router, and then you can use a smartphone app to turn it on, off, or control the lights. So just to give you an example, if we had a Philips Hue here, and if we wanted to make this lamp blink every time someone tweeted something about SenZations, it would be simple as this, just dragging in the Twitter node, setting it to listen to the SenZations hashtag, and then very simple code here just to tell the node, the Philips Hue to flash, and then connecting to the node of the Hue lamp. And the configuration here is just putting the IP address of the gateway, and that's it. So imagine having to do this through code. So, I mean, I'm not talking about Java or C. Even in JavaScript, you would need to import the libraries, write the logic, and do many stuff. It would be an X number of lines of code. But here, with almost no coding, you got a fully IoT example working. So you read some social network, and you interact with a commercial piece of hardware. Yeah, we can also talk offline about this. It's really easy to use, and we got also a few examples later on my talk about Compose. So let's talk about devices and JavaScript, hardware. So I mentioned before about the test cell. These are the features. It's really powerful, and it's a bit expensive, but it comes with Wi-Fi, lots of pins for doing stuff. It's fully open source. And the cool thing is that it's not a Raspberry Pi. It doesn't run any Linux on it, but you can still install NPM modules. So if you want to use something, for example, if you want to do Bluetooth for scanning, and there is a guy somewhere on GitHub that has a Bluetooth for library for Node.js, you can do npm install BLE, and it will work. And yeah, this is how it's done. So if you have ever written Node.js or JavaScript, this should look really familiar. So you just require whatever you need. This is the default TESL module. This is the Bluetooth for library. You say that the Bluetooth module is connected to the port A, and then it scans for devices. And when it discovers a device, it just will log the output. And it's a single board like an Arduino with a Wi-Fi on top of it. Pretty cool. Additional to that, it's the Espruino, which is almost 2 years old, and it's very cheap, so you can buy it for about 30 euros, and it also runs natively JavaScript code. You can also connect it to the internet by connecting the Wi-Fi TI CC3000 module, which is very popular. It has a web-based IDE, so you don't have to mess up with installing drivers or whatever. But also it comes with a modified version of Scratch, so if you don't want to write code, you can use this virtual environment where you can put blocks together, and you can write your application logic just by connecting different blocks and putting the logic over there. So yeah, that's also quite interesting. So yeah, we saw the devices, networks, online services. What else does it take to build an IoT application that is fully end-to-end and sort of scales? I mean, you can select your device, an Arduino or a Galileo board, you write your code, you select your network protocol, you give it Wi-Fi. You can use Node-RED to connect it to Twitter and read some stuff, but what if you want to put some application logic somewhere? Where will you do that? Would you use your own server? Would you go to Amazon Web Services? How would you do that? Yeah, sure, but let's say that you want to build something that scales. So this concerns the backend. So, I mean, when you move away from the device and you go to the backend, again, it depends. There are many options, but in any case, you have to do basic things like, so you have to deploy, you have to push your code to a backend and make sure that it can scale. You have to manage all the APIs, even if these APIs are exposed by you, so other developers can use your application, or if you consume APIs from external web services, like a weather service or something else, and you have to do the data management and the maintenance. So it can be a bit of a mess, even if you just need to simply prototype and have a proof of concept. But it can take a lot of time to identify the right software, the hardware to communicate, all the libraries that you need, find the data, find also the users. And if you're an entrepreneur and you want to make sure that this can scale, it can cost a lot of money. So this is where Compose comes, and we sort of like to think of it as a full end-to-end IoT solution, because mainly what it is, Compose stands for an open marketplace to place objects at your service, but what it actually is, it's a scalable platform as a service, fully designed for the Internet of Things. So it's a platform as a service on the cloud side where you can push your applications and they can scale, and it comes with appropriate tools for connecting devices. So we try to support all the different communication protocols and provide all the libraries. So if you have a Needle Galileo or a Flyport or a SparkCore, you can easily just focus on getting the data from the sensors and directly sending the communication, the information to Compose, and then focusing on the backend. And of course it's open source and it's free because it's a European project. And I mean, we sort of like to consider it as a full gift pack for the IoT. So it comes with everything you would need to build an end-to-end solution. It's based on Cloud Foundry. Have you ever heard of Cloud Foundry? So Cloud Foundry is a very popular open source platform as a service where you can take it, you can install it, and then you just push your applications and scale. Okay, it's not easy as that, but it's much more better than taking your Amazon instances and installing whatever application server you need and database and all that stuff. So we took Cloud Foundry, we added Couchbase for database, we added security, service discovery, Apache Storm for data processing, all the communication protocols you might need for IoT, and also Node-RED as an interface, and we make it as a bundle, and we provide it for free to developers and users. Let's dive a bit into the main components and see what are the features and the functionalities. So the main, the very, very basic component behind Compose is what we like to call Serviodicy. And it's a RESTful API for pushing sensor data to the cloud, but also for communicating with devices. So it's REST like Xyovly and PowerInput, so it supports all the get, post, put commands for sending data, and you can send your sensor data and store them. We support and we provide a very easy way to use Elasticsearch. So you can query and retrieve your data not only on a time scale, but you can make queries like, give me the data that belongs to this location, for example, and it's really fast and it gets the data back. It allows you to push data to the devices. I'm going to explain on some slide later how to do that. And also it allows you to subscribe to notifications. So your application, whether it's a mobile or a web application, can receive a notification when some device sends some data to the cloud. So you don't have to poll the system all the time, give me the latest value or give me any new value at all, for example. Of course, it's free and open source. There is a bundle you can download as an Ubuntu image at the moment, but very soon it's going to be a full thing inside Cloud Foundry. So you're going to be able to download Cloud Foundry, take your hardware, your computer or your cluster of machines, deploy Cloud Foundry and have the full thing that can scale. So pushing data to the device, how this is done and why we sort of consider this as a challenge for the IoT. So this is the web applications and this is HTML. So yeah, web talks HTML. But the thing is that obviously devices talk end-to-end protocols like co-op, MQTT, MQP, HTML5, or even proprietary ones. So how can we have a web-based application that knows only HTTP and can talk HTTP communicate with a device that knows different protocols? So the answer is, of course, to do some sort of bridging. Now, there are only a few other projects doing that, and the most popular one is already an Eclipse project. It's called Ponte, and what they do is they expose a RESTful API for communicating over MQTT and co-op. So you use the REST interface for your web application to send something, and this automatically is translated and sent over MQTT or co-op to your connected device. What we do inside Compose is we complement that, and we support MQTT, Stomp, WebSockets, and also co-op in the near future. So we try to provide a bridge with all the different end-to-end protocols that exist and are popular and are likely to be used by developers, and expose them through a RESTful API. Not only for pushing data back to devices, but also receiving notifications when something happens on the device. Now, why do I need to push data to a device? And why do I need a bidirectional protocol? Is it a hard question, or are you so tired? Why do I need to push data to a device and I need a bidirectional protocol? Exactly. It's really important because in many cases you want to act on a device and you don't want the device to poll the server all the time saying that you have an actuation, you have something. So, yeah, this is why these protocols exist. But if you have a web application and you need to find a way when you click the button on the browser that this event goes back to your Arduino through MQTT, you need the bridge. Well,
Also for device management.
also for device management. You want to reboot the device, you want to ask information like give me back the battery status or whatever, things like this. So, yeah, at this point, to hopefully trigger your interest, I'm going to show you a video of a small demo we did a few months ago. So what I have here is, so this is an Arduino with a Wi-Fi shield on top, and in the middle it's the same groove shield you got over there. And I have, this is like a distance sensor, and this is a colorful, it's a LED, RGB. So this little guy here with a Wi-Fi shield is connected to the local Wi-Fi network. And on my phone, I got the 3G connection and have a web page, a web application. And what I'm doing is that I'm tilting the phone, and while I'm tilting it, there will be a small square there. And when I tilt it, the color changes. And this triggers an action to the device and changes the color. So I can act on the device while I'm using here web, but this guy talks only MQTT. And vice versa. When there's going to be an event from the sensor, again, it will go through MQTT and it will be delivered on the web application using WebSockets. And the whole thing is, the whole bridge, while we are in Germany there, the bridge is in Barcelona. And I'm just showing this to you just to show you how fast this can be done using MQTT. So we got the connection to the Wi-Fi. Now it's connected to the broker. The first interaction takes a bit of time because the network is congested. But after that, so you see it's green, it's blue, it's almost instant. And I'm saying again that the phone is on 3G, total different network, and that guy is Wi-Fi. And when I did the actuation of the device, it went really fast on the phone. Cool. And all that with Compose and just using a very simple RESTful API here and WebSockets and MQTT client over there. So going back to the slides. Yeah, so this is Serviodyssey and this is what it's offering. Not just storing data like Xively or the other platforms, but also integrating different protocols and the ability to act back on devices. How did we build it? We tried to avoid making things from scratch. So we made a very good search and we wanted to see what people and developers are using, and we tried to integrate as many popular open source frameworks as possible. So we use Apache Storm to process the incoming sensor data and be able to do things on them, like classify them or I'll send them back to the user. We use Elasticsearch to make complex queries on the data that is stored, Couchbase DB, and Apache Apollo is the bridge that gives us the implementation of all these bidirectional protocols like WebSocket, STOM, MQTT, and we expose them through the RESTful interface. This is just a visualization of how things are working. So you got your devices that send data. You can subscribe using binary protocols, and you get notifications when new data arrives. And also you can push back. And for the users, you can get queries, you can make GET requests, and read the data back. Everything is online, and I also got the links, so you can find the information when I give you the slides. So yeah, this is COMPOSE. So I talked about Seriodyssey. I'll talk a bit about glue things. We have a nice web interface where you can simply register to the system, you can create an account, you can get a token, and you can start playing with devices. We're going to see an example. We got libraries and SDKs on GitHub. So if you want to build an Arduino example or an example for a mobile application using Android or iPhone, we got that stuff already, so you don't have to worry how do I implement MQTT on Android or iOS. We just take the libraries, and it's quite easy. I'm going to show you later how it works. Yeah, and of course we got Node-RED, so you can implement your application logic, but just dragging flows and not writing any single piece of code. Yeah, we also sort of try to take security seriously, so there is, at every single component inside COMPOSE, we got things like an identity management, a policy decision point, so there are rules and user access control and device access control. So you can define what device can store what data and who can have access to this data, and also everything is monitored. We provide service discovery, because the idea is that, again, we want to allow people to build full end-to-end applications. And an end-to-end IoT application is not just, taking your smartphone and controlling your light bulb. It's more than that. It's integrating external APIs, like a traffic API or a weather API, that would allow the lamp to flash or change color when there is a thunderstorm coming, or when there is heavy traffic in the morning and you want to make sure you wake up earlier, for example. So if you don't know what services to use, how you can do that? This is the sort of problem we also are trying to tackle by doing service discovery. So we have partners in the UK and the Open University that help us doing this. So far, what we got is a very interesting node for Node-RED. It's provided by COMPOSE partners. So what you do, you drag the node on your workflow, you double-click, and here you can enter a Swagger API endpoint. So in this example, they put an API that has a service for pet stores. So once you put the API, it automatically generates the list of resources that are supported. So for this particular API, you can have a resource about the pet, the user, or the store. And let's say that we select the store, then it automatically tells you what the available methods, like if you want to place an order, delete an order, or get an order by the ID. So what you can do with that is, for example, if you can have a sensor that can detect, if the food of your dog is finishing and you want to automatically place an order, you can do that through Node-RED and by having just this node. Now, eventually, because we are halfway through the project, what you will be able to do is that skip the part where you put the API and just type in pet store API, and it will be able to generate the list of available services and then do these things a bit easier for you. So, yeah, how can I use COMPOSE to build an application? Let's try to sum this up a bit. So let's say you got an idea and you want to connect a smart device or a dumb device to the internet. So what you do, you go to COMPOSE GitHub, you take the libraries for the device, depending on what sort of device it is, it's a mobile device or an Arduino, for example, and those libraries enable you to communicate with the COMPOSE cloud. So you can both store sensor data or actuate on the devices. Then you can discover external services that exist and integrate them, and you write your application logic on top of it. either on Node-RED or JavaScript. And then simply you can deploy, manage, and publish it. All that on the Cloud Foundry environment, which is a platform as a service. Let's see it a bit like step by step and how you could also use it during your projects here. So what you need to do is go to gluethings.com, which is the front end for Compose and Serviodyssey. You go on the platform Smart Object Manager, and you register for free. It's really fast, and then you log in. And once you log in, it's quite similar to Xively and Parimpo and the other web interface. You got a list of the devices you might have already created or not. So you click to the Add New Device. You add things like a name, a description. You can, if you know that your device already has a very simple sensor, like a temperature sensor or something else, you can choose from the list, or you can manually do that like in Xively. You can say that my device has 2 sensors. This sensor is a temperature sensor, that sensor is a humidity sensor. Once you complete this step, you get all the information you need to connect your device to the internet and start pushing data to Compose. So you get the ID for your device, and also you get your API token, which authenticates you, the device, and enables it to push data to Compose. And that's the endpoint. But this is all it gets. This is all what you need to do. Then you can simply go to GitHub and the Compose repository, and let's say that you want to connect your Arduino and push data. And let's say that you have an Ethernet connected Arduino. So we provide you the library to do that, and you don't have to worry, you don't have to implement the HTTP request, and you don't have to mess with all the HTTP communication and the protocol. It's really simple. You just put your authentication key, you read your sensor value, you say that this is my temperature, and I'm this user, and you can also put contextual information like the location, and then you just submit it, and that's it. The information goes on the cloud, and that's all you need to do. Similar thing for the SparkCore, for the Flyport, or if you use an application on a mobile phone like an Android or an iPhone. By the time you do that, you can go back to your glue things, and in real time you can see the values posted. So you can also do some sort of debugging before you even start building a real application. You can make sure that your sensor, your Arduino, is indeed talking to the cloud and posting data. Then what is the next step? Very simple. You can go to your Node-RED, which in the near future will be integrated inside GlueThings, so you don't even have to install Node-RED. And what you do is that you say, okay, I got my Arduino pin, and I push data to Compose, to our Compose Node-RED node. And I can also debug it and see if it actually gets there. And let's say that every 2 minutes, I want to read this information back. I can tweet it, I can process it and change the color in the hue lamp, or I can simply write it. And I mean, it's really up to what you want to do, and your imagination is the limit here. You've got all the components you need to start building applications that either push data to the platform or read data from the platform without writing any single line of code, or almost. Or if you want to do something complicated like, I don't know, data processing or some classification or whatever, simply you go on the Cloud Foundry, you push your Node.js or Java code, you use the APIs to read the data from Compose or push the data, and it scales, and that's it. So, if you want to learn more about Compose, this is the main URL. Also follow us on Twitter, and yeah, we got many social events, so hackathons and workshops and competitions. Is anyone from Barcelona or Italy, North Italy? So we have a connected hackathon on the 20th of September. It's going to take place simultaneously in Barcelona and in Trento. And we're going to use Compose, and we're going to have teams in Barcelona connecting objects to the internet that will interact with objects in Trento and vice versa. And yeah, and this is me. I'm both a researcher and I blog a lot about the IoT. I'm a maker. I built a lot of stuff with Arduinos and other boards. And I'm also the author of one of the first books that came out 2.5 years ago about the Arduino and Internet of Things. And that was it. Thank you.